Hello, welcome back to the channel. So in this video, we'll be covering some important indefinite integrals that you will probably have to know in order to excel at these type of questions when you have to take the definite integral of some very common functions that you see in math. So it's basically the same case for indefinite integrals as well. And what indefinite integrals are, they're basically when you're taking the integral of a function which doesn't have an endpoint. So you're taking the integral of a function in general, you're taking the general area under the curve of that function. When you don't have any endpoints, that is the point when they are known as indefinite integrals. So these are a popular list of functions for which most of the questions will be based upon. So you'll either get a combination of all these functions and you'll have to calculate the integral of that function. And we'll do a couple more examples in this video and in the next video as well in order to reinforce these concepts. So stay tuned for that as well. But the most important thing about this video is this chart. So at this point of time, the most appropriate approach would be to remember all these definite integrals because these are very quite popular indefinite integrals, and knowing them will definitely help you solve these indefinite integral type of questions really quick. So that is why I will cover some examples. So basically when you have to integrate a function, you know that it's opposite of differentiation, right? So whatever is on the right hand side, since this is my integral, so if I differentiate everything that is on my right hand side, I'll get the left hand side, right? Because integration is the opposite of differentiation. So if I integrate this function, I get this, and if I differentiate this function, I'll again get my original function. So that is the basic idea about integration and differentiation that we already covered in the last videos, right? So we'll start with some basic examples. So the integration of 1, which can also be represented as, so whatever you see on the left hand side is basically this expression, integral, and the function over here, for example, in this case it's 1, and then you'll have dx. So if you're calculating integral 1 dx, you notice that there are no endpoints, right? So if you don't specify any endpoints, that is basically an indefinite integral. And based on this expression is equal to x plus c. And we already covered this constant of integration in the last videos as well, because since we know that the differentiation of a constant is 0, so whenever we're taking the integral of a function, we don't know if the function has a constant term as well, right? So even if I will differentiate x, I'll get 1. If I differentiate x plus 1, I'll get 1 as well. If I differentiate x minus 2013, I'll get 1 as well, right? So that is why we take this constant of integration in order to generalize the indefinite integral of a function. So that is why whenever you'll have the integral of these functions, you'll always see this constant of integration, right? At every point of time. And you definitely don't have to forget to add this constant of integration at the end of your answers, because if you don't end your answers, if you don't end your integral answers, the indefinite integral answers with these constant of integrations, the marker would definitely deduct marks based on that. So that's it for now. And again, a trick if you want to remember everything, whenever you're integrating a function, you must have covered this in your differential calculus as well, when you took an ansatz of um, an antiderivative. So that is basically the same thing you'll do in this case as well. On the left hand side, whenever you'll have a function, think of what would be the second function for which I'll differentiate my second function and I'll get the first function back. So you can also try this approach, but at this point of time, it's easier to just learn all those definite integrals, and that will probably make your calculations for indefinite integrals much easier. So let's do a simple example in this case. Don't worry, we'll cover a lot of problems on this concept because this is perhaps one of the most important concepts in the course as well. So we'll do multiple questions based on calculating the indefinite integral of a function, right? And we'll start with basic functions, and then later on we'll combine two or more functions in order to make questions more complicated and calculate them easily by breaking down those components and calculating the indefinite integral of each component that we already know for, right? So in this case, we'll combine the fundamental theorem of calculus and calculate this expression over here. And you would probably remember from the previous videos that the fundamental theorem of calculus suggests that whenever you're taking the integral of a function fx dx from a to b, it is equal to capital F of b minus capital F of a. And the capital F is basically the integral. That would be the function which is represented by the indefinite integral of that expression. So for example, in this case, our f of x, the capital F of x would be the integral of e to the power x dx without the endpoints. That is basically the general expression for capital F of x in this case. And now, since we already covered these indefinite integrals on the last slide, we'll just pick the integral for e to the power x. So as you clearly see in this case, if we take the integral of e to the power x, the definite integral of e to the power x, it's e to the power x plus c, which can also be checked by differentiating this expression. So you know, if you differentiate an exponential function, it stays exponential, and the differentiation of a constant is 0. So if you differentiate this expression, you'll get e to the power x, right? So let's start solving this question. So first of all, again, we have to calculate the indefinite integral in order to get the capital F of x. And you'll see that the constant of integration won't play an important role in this case when you're calculating the definite integrals, and we'll see that point in a bit. So let's solve that. And we know based on the chart that we have, the integral of this expression is e to the power x plus constant of integration. And now, since we have to calculate, in this case, e to the power x dx from 2 to 7, right, that would be equal to f of 7 minus f of 2, where our f of x is this in this case, right? So let's calculate f of 7 first. If we calculate f of 7, we just have to substitute x equals 7, right? Because our x is equal to 7, we just have to substitute x equals 7 into this expression, which would be e to the power 7 plus c, right? And similarly, let's calculate capital F of 2. So in order to do that, we'll do the same thing. We'll substitute x equals 2 in the above expression. And if we substitute x equals 2 in the above expression, you'll notice that it would become e square plus c. And you'll always notice this thing while calculating the definite integral of a function, that your constant of integration will always cancel out. So in this case, your definite integral would be e to the power 7 plus c minus e square minus c. So this and this cancels out. The final answer becomes e to the power 7 minus e square, and this is equal to integral 2 to 7 e to the power x dx. So that is why the constant of integration doesn't play an important role in definite integrals, because it will always get cancelled out no matter what, but it plays a very important role when you are calculating indefinite integrals. So if there was a question based on calculating this expression, your answer should be in the form of this, which should include a constant of integration. And while solving the question as well, you'll also represent the constant of integration no matter what, even if you know that it's going to get cancelled out, but you'll still represent this in the expression because your capital F of x, the original function, is this one. So that's it for this video. I hope this video covers the concepts of definite integration and how we can use indefinite integrals in order to solve definite integrals. Again, we'll do a couple more examples in order to reinforce these concepts, and we'll start from the basic functions to the complex ones. So stay tuned for that. Thank you so much for watching. Follow the channel in order to get notified about the other videos that I'll be uploading. Also, feel free to comment down in this video if you have any doubts. Stay tuned. Thank you so much for watching. Bye bye. Take care.